Assalamu alaikum. Hello, everyone, and welcome to Mathematics with Shahab Yaqub. Now, in today's lecture, we'll be focusing on this paper, which is paper 5, that is probability in S1. And this is from May, June 2020, and this is variant 1. Now, the time limit is 1 hour, 15 minutes, which is 75 minutes. So, what I'll do is that we will also time ourselves for this particular paper. So let's get started. And this is 10:09 p.m. and we are starting with this. So now, very first thing is that we should go through the instruction. Let's say you're seeing this paper for the very first time. It says answer all questions. The color of the pen, black or dark blue. Pencil for any diagram. Write your name, center number, and candidate number in the boxes at the top of the page. That's the candidate number, center number, and the candidate number and the candidate name. Write your answer to each question in the space provided. Do not use erasable pen or correction fluid. Do not write on any barcodes. If additional space is needed, you should use the line page at the end of this booklet. The question number or numbers must be clearly shown. You should use a calculator when appropriate. That means you don't have to always use a calculator where appropriate. And then it says you must show all necessary working clearly. No marks will be given for unsupported answer from a calculator. This is something that candidates really need to understand, that unsupported answers will not earn you any mark. Give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angle in degrees. Now, this thing is for P1. And this thing is for both P1 and S1 and P3, M1, S2 for everything. Unless a different level of accuracy is specified in the question, the total mark is 50. The number of mark for each question or part question is shown in the bracket. So now, approximately, I took 1 minute or 2 minutes. Actually, it's 10:11 now. This is for reading the instructions. Of course, you should have read the instructions before you start the exam paper because it's the same instruction all over. So now I'm starting at 10:11 p.m. That is the start of this past paper session. Let's get started. Now, the first question, it says the score when 2 fair 6-sided dice are thrown is the sum of the 2 number on the upper faces. Part A, show that the probability that the score is 4 is 1 over 12. Now, this is a simple question of probability. And when 2 numbers are thrown, actually 2 dice are thrown, and it's the sum of the 2 numbers. So we know that number of possible outcomes at 6 into 6, that is 36. How can we obtain a 4? A 4 can be obtained as a sum of 1, 3 or 3, 1 or 2, 2. You don't have to draw the whole diagram. So 3 options are there. 3 ways are there. So therefore, probability of getting a score of 4 is 3 over 36, which comes out to be 1 over 12, and that is what's written over here. So the first part is done. Now, the next part. It says the 2 dice are thrown repeatedly until a score of 4 is obtained. Now, this is the key word, that is until. It is thrown repeatedly. That means it's a geometric probability distribution. You need to diagnose the question. What exactly is it about? The number of throws taken is denoted by the random variable x. Find the mean of x. Now, first of all, let me write this thing. X follows a geometric distribution, GEO. That's the short form for geometric. And the probability of success, that is 1 over 12. Now, the very first thing that we should be aware of is this thing, that expectation of x is the reciprocal of probability. The probability of success is this thing. So therefore, the reciprocal of this thing is 1 divided by 1 over 12, which comes out to be 12. That is the expected value. Again, something very basic, but for 1 mark. Now it says find the probability that a score of 4, again, the success is getting 4. You are throwing it until a score of 4 is obtained. Find the probability a score of 4 is first obtained on the 6th throw. So now there are two results which are very, very common. Let me highlight it for you. The first result that we should be aware of, let me write at this corner, one result in red and the other result in green, which is very, very common. They ask for it all the time. The first one is probability x lesser than or equal to n. It's 1 minus q raised to power of n. And let me just make the box a little bit better. So let me erase it. And over here, let me choose the red color marker. And it goes like this. So probability x is lesser than or equal to n is 1 minus q raised to power of n, where q is the probability of failure. And similarly, we have probability x greater than n, it's q raised to power of n. Now our focus is on the score of 4 is first obtained on the 6th throw. That means what we can do is that this can be used in part D, it could be used in part C. I have first listed it down. That is probability success on 6th throw. That means there are 5 failures and the success is the 6th one. So the failure is 11 over 12 because probability of success is 1 over 12. Probability of failure is 1 minus probability of success, which is 11 over 12. So 11 over 12 is written 5 times multiplying by itself. That's raised to power of 5 into 1 over 12. And you just multiply it out. That is 11 power 5 over 12 power 6. And that will be the answer. We can write it in the fraction form. We have the mark scheme attached to it, most probably. And we can also double check this thing. Now, what about this? Probability x is less than 8. Is it related to this result, which is very useful, or this particular result? It's related to this result almost. This is lesser than 8. Now, if I draw a number line of lesser than 8, so let me write over here, this is 8. 8 is not included. Lesser than 8 is actually a solid circle, and this is lesser than or equal to 7. So probability x less than 8 is probability x less than or equal to 7. This is the result that I'm interested in. That is 1 minus 11 over 12 raised to power of 7. Now, I have shared the PDF with you. Why don't you go ahead and open up the PDF? And let's look at this one. That is the one that I shared earlier. And this is 51 May, June 2020. And I'm looking up the PDF. Now, the first answer, that's 1 over 12. That was done. So you obtain 1 mark. Over here, reciprocal of probability, that is 12. And this thing is coming out to be, this one is a big number, 161,051 divided by 2985984. If you want to write in the fraction form, or you can write this thing as 0.0539, correct to 3 significant figures. So now this is all good. This is all good also. And this one, 1 minus 11 over 12 raised to power of 7. This comes out to be 16344, 16344,637 divided by 358, 358, 31808, or that is 0.456, correct to 3 significant figures. So that's how this particular question is done and dusted. Now the time right now, it's 10:18, and this is the first time that we are starting with a paper. So let me write over here 10:18 p.m. That's the end of question 1. So question 1 took around like 7 minutes with all the narration, with all the background knowledge that I'm giving you. That means if you are doing it on your own, definitely it should be taking lesser than this. So now let's move on to the next thing. That is, find the number of different arrangements. Now the question is about arrangements that can be made from 9 letters of the word jewelry, in which the 3 E's are together and the 2 L's are together. Let me also read the next part. Find the number of different arrangements that can be made from 9 letters of the word in which the 2 L's are not next to each other. And this particular question is only about permutation. So that is NPR, that is permutation. Now let me focus on this thing. That is the word jewelry over here. So if I write it, that is JEWELLERNY. So now over here, if I focus, there are 3 E's and there are 2 L's, and then there is a J, there is a W, there is a R, there is a Y. Altogether, these are 9 letters. Now, first of all, it says the 3 E's are together. So let me write the 3 E's together and let me draw a box around it. Let me write the 2 L's together and let me draw a box around it. And what is left? So now what are we left with? We are left with J, W, R, and Y. So there are 2 boxes over here. The 2 boxes because they were 2 separate together. So first of all, the 2 E's were together, the 3 E's. The 2 L's were together, and then J, W, R, Y. So now, first of all, let's focus on this. That is 1, 2, 3, 4, 5, 6. That is 6 factorial. That is the first thing. If I focus on the blue box with the 3 E's, it should be 3 factorial divided by 3 factorial because they are identical E's. If I focus on the L's, that should be 2 factorial divided by 2 factorial for the L's. So what am I left with? I'm simply left with 6 factorial, and the value of 6 factorial is 720. That is the answer for this particular part. All good, all clear? Now let's focus on the next part. Find the number of different arrangements that can be made from 9 letters of the word in which the 2 L's are not next to each other. So this means the 2 L's are separated. So let's write the 3 E's. So the 3 E's are there. So 1, 2, and 3 E's, and then J, W, R, and Y. And there are blank spaces. So let me make it thicker. That's 1, that's 2, that's 3, 4, 5, 6, 7, and 8. So the 2 L's could be there, any one of these 8 spaces. So what should I write? I should write that this should be 8P2. So this is 8P2, but they are identical L's divided by 2 factorial for the L's. And what about these 7 spaces? So this is 1, 2, 7 alphabets, 3 E's and J, W, R, Y. They can be arranged in 7 factorial ways divided by 3 factorial for the E's. So this 3 factorial is for the E's. And then you can simplify this thing and again look at the mark scheme or use the calculator, whichever one is more convenient to you. And this is question number 2. So now in 2B, the answer is 23520. So this is 23520. That is the number of ways in which the arrangement can be done. So now look at the time. That's 10:23. Go back and write over here. So now 10:23 p.m. That's the time for the end of question number 2. So these are the ending times. The starting time is 10:11. First question was done by 10:18. Second question was done by 10:23 with all the narration that I'm doing for you people. Now, the third question. It says A company produces small boxes of sweets that contains 5 jellies and 3 chocolates. Jamil chooses 3 sweets at random from a box. So now it says draw up a probability distribution table for the number of jellies that Jamil chooses. And this part is something else. So now for 4 marks, we have to focus on this. Now, what is the question about? The question is about probability distribution. And this chapter is also known as DRV, discrete random variable. Now, what is the best way of working it out? Now, you have done probably questions like this, many questions like this. And this one, let me give you the hint. Let me write over here jellies, and there are 5 of them. Let me write over here chocolates. There are 3 of them. And all together, we need a total of 3. That means if I'm focusing on jellies, so let me write 0, 1, 2, and 3. And over here, let me write 3, 2, 1, and 0. So now, once this is done, what needs to be done? Now you have to write out all the possible combinations for this particular question. So what we can do is that we can write that is 5C0 into 3C3, which comes out to be 1. Let's write 5C1 into 3C2. 5C1 is 5, 3C2 is 3, that is 15. 5C2 is 10, 3C1 is 3, that comes out to be 30. And 5C3 is also 10, 3C0 is 1, that comes out to be 10. So altogether, the possibilities are 30, 40, 50, 55, 56. That is the possible number of ways. And if I am thinking about writing down the probabilities, so the probabilities are very obvious. Probability x is equals to something. Let me first draw brackets over here like a template, equal. And this is 1 over 56. This is 15 over 56. This is 30 over 56. This is 10 over 56. And we are writing from the perspective of jellies. So this is 0, this is 1, this is 2, this is 3. This is x is 0, x is 1, x is 2, x is 3, where x is the number of jellies obtained. That is the working that needs to be done. Since we need a table, why don't you go ahead and draw up a table? So let me just draw a box like this. And let me write over here x. Let me write over here probability x is equals to x. So this is 0, this is 1, this is 2, this is 3. That is 1 over 56. 15 over 56. 30 over 56, and this is 10 over 56. That's how the table is formed. So that is question 3, part A. So this thing is all done and dusted. Now let's move to the next part. What is this about? I would like you people to first go through this. What exactly are they referring to? I hope you have read it by now. Let me read it for you. The company also produces large boxes of sweets. For any large box, the probability it contains more jellies than chocolates is 0.64. 10 large boxes are chosen at random. Find the probability no more than 7 of these boxes contains more jellies than chocolate. So now the very first thing that I should realize is that more jellies than chocolate, this is your probability of success. So probability of success is 0.64. Probability of failure is 0.36. Number of trials is 10. In other words, it's a question of binomial probability distribution. So now let me write over here, this is binomial probability distribution. Of course, it's part of DRV, but it has got its own personality, its own identity. So yes, it's part of DRV, but the second part is technically binomial. So X follows a binomial distribution 10, 0.64, no more than 7. That means less than 7. So now we will write actually no more than 7. That means 7 is included, at most 7. So let me write in this word with which we are more familiar, at most 7. So probability X is lesser than or equal to 7. So probability X is lesser than or equal to 7, which is too much to calculate, which is 1 minus probability X is greater than or equal to 8, which is 1 minus big bracket 10C8, 2 brackets over here, 10C9, 2 brackets over here, 10C10, 2 brackets over here. What goes inside the bracket? Probability of success, probability of success, probability of success raised to power of 8, raised to power of 9, raised to power of 10. And what is left? Probability of failure, that is 0.36, that is 0.36, that is 0.36. The difference between 10 and 8 is 2, 10 and 9 is 1, 10 and 10 is 0. So this is what needs to be calculated. And then the overall answer after subtraction is 0.759, correct to 3 significant figures. So now the time is 10:30. Again, I'm scrolling up and I'm writing down over here. This is 10:30 and plus minus a minute, because maybe the time could change any minute. And that is question number 3. And let me write over here question number 4. Let me write over here question number 5. And over here question number 6. And over here question number 7. I think there are 7 questions in this particular paper. So now let's go back and let's move on. Now we have question number 4. So now again, I would like you to read it first. Maybe some of you have tried out this particular question, and let's see how it goes. So now question number 4, what does it say? It says, let me start underlining. It says that in a music competition, there are 8 pianists, 4 guitarists, 6 violinists. 7 of these musicians will be selected to go through the final. How many different selections of 7 finalists can be made if there must be at least 2 pianists, at least 1 guitarist, and more violinists than guitarist? So first of all, I hope you have realized by now, this is a question of NCR. So now they give question of NPR and NCR differently also, and maybe sometimes they are connected in one question. So let me write over here, that is the 3 things, which is pianist, and this is guitarist, and let me write over here, and this is the violinist. How many they are? That is 8, that is 4, that is 6. And altogether, I need 7. So at least 2 pianists, let me write over here 2. At least 1 guitarist, let me write 1 right now. And more violinists than guitarist. That means the violinist should be more than guitarist. So first of all, let me write a 4 over here. So now does 2, 1, 4 adds up to 7? Yes, it does. And this is at least 2 pianists, at least 1 guitarist, and more violinists than guitarists. Now, what I can do is that let me fix the pianist as 2. And let me play around with these 2. What if I change the guitarist to 2? What if I change the violinist to 3? Because it has to add up to 7. This is also good. First, focus on writing down. The calculation can be done later. What if? So don't be shocked if I write a wrong answer. Okay? I'm doing it for you people so that you understand. What if you write 2 and 3 and 2? This will be marked as wrong. Why? Because the violinist has to be more than guitarist. So grab your eraser and just erase it. There is nothing to worry. All good, all clear? So now I have exhausted the options for two pianists. So now let me focus this. The two pianists, these options are exhausted. What if I increase the number to 3? Because it's at least two pianists, at least one guitarist. Let me choose 1 over here. 3 plus 1 is 4. So now this will be 3 over here. Altogether, it has to be 7. Now I have increased this to 3. Can I let me write it again. What about a 3 and a 2 and a 2? No, I cannot. It will be marked as wrong because more violinists than guitarists. This condition also needs to be fulfilled. So let me erase it again. What if I increase the number of pianists to 4? Yes, I can increase that. If I increase this option to 4 and this option to 1, can I write this one as 2? Yes, I can, because the number of violinists is greater than number of guitarists, and I think that's all about it. Because I cannot go to 5. If I choose 1, this will be 1, and these two would be equal, so that's not an option. So these are the 4 possibilities that we have. And let me write down all the options. You select the pianist from the pianist, that's 8C2 into 4C1 into 6C4. Then 8C2 into 4C2 into 6C3. Then 8C3 into 4C1 into 6C3. And this is 8C4 into 4C1 into 6C2. So all these options will be calculated and you will get the total right over here. So let me go to the option, the mark scheme, which you people also have. And which question is this? This is question number 4. So question number 4 is over here. So 8C2, 4C2, 6C3, 8C2, 4C2, 6C3, that is 3360. Do double check my working. 8C2, 4C1, 6C4, that is 1680. And then 8C3, 4C1, 6C3, that is 4480. And the last one, 6C2, 4C1, 8C4, that is 4200. So now all together, this is 13720. This answer is exact. Do not round off because exact answers need no rounding off. So this is question number 4. Then there is a blank page. So now let me go up, scroll up all the way. And question 4 is done at 10:36 p.m. So now 4 questions are done. Now, after the blank page, we have question number 5. And what is this question number 5 all about? I think it looks like a tree diagram. That experience should speak for itself. You look at the question, and then it's a probability tree diagram, and most probably it will have something conditional over there. Let me just go through it. Find the probability given. That's the keyword that I was looking for. That is given, which means it's a conditional probability question. So 4, 2, 6, 6, and 2, that's 8 marks. Now it says, on Monday, Rani cooks her evening meal. She has pizza, burger, or a curry. So there are 3 options over here. That is pizza, burger, or curry with probabilities 0.35, 0.44, 0.21 respectively. When she cooks a pizza, Rani has some fruit with probability 0.3. So with pizza, the fruit is 0.3. With burger, the fruit is 0.8. When she cooks curry, she never has any fruit. That means the probability is 0. So now let me draw the tree diagram. So first of all, let me draw 3 branches like this. The first branch, the second branch, and the third branch like this. So it goes like this. And then there is the option of fruits. So now over here, let me just write a fruit thing and not a fruit like this. Let me copy this thing and let me paste it over here. And let me also paste it over here. Okay, so now let me write the values. First of all, P for pizza, B for burger, C for curry, and then we have fruit, no fruit, fruit, no fruit, fruit, and no fruit. The corresponding probabilities are, first of all, 0.35, 0.44, 0.21. You can write a 0 before. And then we have with pizza, fruit, that's 0.3. Therefore, this is 0.7. And then this is 0.8 and 0.2. And she never has any fruit for some reason. This is 0.0. This is 1.0. So now this is the fully labeled tree diagram. For your purpose, you can write pizza and fruit, pizza and no fruit, burger, fruit, burger, no fruit, curry, fruit, curry, no fruit. And then these are the possible outcomes and the corresponding probabilities, whichever one you need, that we will write down later on. Find the probability Rani has some fruit. That means we are interested in these three options. That is this option, that is this option, that is this option. So this option is 0.35 into 0.3. This option is 0.44 into 0.8. This option is 0.21 into 0, which will become a 0. That is the first thing. Now, the second part, find the probability Rani has some fruit. So part B is 0.35 into 0.3. So 0.35 into 0.3. And then we have 0.44 into 0.8. And then we have 0.21 into 0. And this comes out to be 0.457. This is exact. That's the probability. Find the probability Rani does not have a burger, given that she does not have any fruit. So now we are interested in this thing, and I'll do it separately. That is no fruit, no fruit, no fruit. So now over here, this is 0.35 into 0.7. This is 0.44 into 0.2. This is 0.21 into 1.0. 0.35, 0.7. Let me write over here, first of all. Excuse me. So that is this thing. Hold for a second. And let me draw a line like this. So the condition goes down in the denominator, given she does not have any fruit. So not having any fruit is this thing. The pink ones, 35, 7, 44, 2. So this is 35, this is 7, this is 44, and this is how much? This is 44 and 0.2, 44 and 0.2, and 0.21 into 1.0. So these three things are the ones that goes down in the denominator. Now, a lot of people ask this question that I could have simply subtracted this thing. The answer is yes. But I need to pick the relevant one that should go up. She does not have any fruit and does not have burger. So now if she does not have burger, what does she has? So this is pizza, no fruit. This is burger, no fruit. This is curry, no fruit. So therefore, this one is forbidden. This is correct. This is correct. So therefore, we will write 0.35 into 0.7 that goes up. And we have 0.21 into 1 that goes up. So therefore, this is 0.455 divided by 0.453. And this is 543, my bad. So this is 543. And when we divide, what do we get? we get this answer as 455 over 543. This is perfect. Or if you are a decimal fan, so therefore 0.838 correct to three significant figures. This is also good. So that's how this particular question of conditional probability is all done and dusted. Again, let's scroll up. So for question 5, what's the time? Time is 10:43. So this is 10:43 and that is 5 questions are done. And then we will do the analysis of each question. Don't worry about that. So now it's time to go to question number 6. That's right over here. Question number 6. Let me start underlining. It says the length of female snakes of a particular species are normally distributed with mean 54 and standard deviation 6.1. Find the probability that a randomly chosen female snake of the species have length between 50 and 60. So first of all, part 1 is normal distribution. And then we will look at the later parts. So I'll write, let me use the symbol X for female snakes. X follows a normal distribution 54, 6.1 square. We are looking for the probability. Probability X lies between two values. One is 50, the other one is 60. Standardize. Probability Z lies between 60 minus 54 over 6.1. 50 minus 54 over 6.1. Close the bracket. Probability Z lies between two values. One is positive, one is negative. So grab your calculator and take out these values. Let me use my calculator. So now, hold for a second. Let me just erase this thing. This thing is done. And this thing is done. Okay. So now this value, the negative value, because 50 is lesser than 54, it's coming out to be negative 0.656. And we are working in 3dp. Why are we working in 3dp? Because that's the limit of the normal distribution table. That is the Z table. So we have to work it out. And this value over here, the positive value, that comes out to be 0.984. Now the rule is whenever we have a normal distribution curve, and yeah, this is also good. And then we have one value which is positive, one value which is negative. So this is the negative value. And this is the positive value irrespective of the size. And we are looking for this probability. This is rule number 7. So this is rule number 7. That probability Z lies between two values. This is negative. This is positive. That is phi of B. That means read the table for the probability plus phi of A minus 1. So this is phi of 0.656. Discard the negative sign because there are no negative Z values. Plus 0.984 minus 1. This comes out to be, also keep your normal distribution handy, 7441. This one is 8375. And then subtract 1. This comes out to be 0.5861. And the final answer is 0.586, correct to three significant figures. These values that you get from the Z table, the probability values are always given in 4dp. They are given in 4dp. So there is nothing to worry. Just work in 4dp. And the final answer should be three significant figures. So that's the first part that I've done. Now, let me also check my WhatsApp. And I hope this is all good, all clear. So let me just hold for a second. Just convert it over here. And what other things am I looking for? I think it's all good. Okay. So now let's look at this question. It's an extension of the same question. So this is normal continued, dot, dot, dot. Now it says the length of male snakes. So let me use another color. The length of male snakes of the species also have normal distribution. A scientist measures the length of a random sample of 200 male snakes of these species. He finds that 32 have length less than 45, 17 have length more than 56. Find estimates for mean and standard deviation of the length of male snakes of these species. Now over here, the working that we are doing, now this working is for what? This working is back solving. We have to work out from the probabilities. Now, first of all, let me write the first statement. 32 out of 200. This is 17 out of 200. 32 out of 200, they have length less than 45. And 17 out of 200, they have length more than 56. So I hope you are getting what I'm trying to imply. You have to convert these words into equations. So first of all, we will write X follows a normal distribution. The mu is unknown. The sigma square is unknown. It's a question of simultaneous equation and back solving. Probability X lesser than 45 is 32 over 200. And over here, probability X greater than 56 is 17 over 200. Got the idea? Now, 32 over 200 is lesser than 0.5. So what will we do? We will write probability X greater than 45. 200 minus 30, 170, 168 over 200. I have subtracted the inequality. I have flipped the inequality and subtracted the probability from 1. The same scenario over here. Probability X lesser than 56. 200 minus 10, 190 minus 7, 183. This is 183 over 200. Now we'll be working in these terms. So this is one equation that we are looking for. That is this one. And this is the other equation right over here. So now you have to work it out. Now this is 168 over 200. This is 84%. So for 84% for 0.84 probability, go to the table. The corresponding Z value is 0.994. And 183 over this value, 200, that is probability of 0.915. The corresponding Z value with no respect for sign, that is 1.372. And then we will take care of the positive negative. Now the rule is that if the probability is at least 0.5 and there is a greater sign, we will take Z value to be negative. If the probability is at least 0.5, which we have already taken care of, so now this lesser sign means Z value is positive. Just take care of this. So what 2 things or 3 things that you have done? The first thing, words converted to equation. Second thing, probability, back solving, get the Z value. Probability, back solving, get the Z value. Third thing, take care of the positive negative at the beginning, and then it's an easy stuff from here. So now over here, if I'll write probability Z greater than 45 minus mu divided by sigma is 0.84. Probability Z greater than some value is 0.84. What is that value? 0.994, and give it a negative sign. So therefore, 45 minus mu divided by sigma is negative 0.994. 45 minus mu over negative 0.994 is sigma. That is equation number 1. Over here, the equation number 2. Probability Z lesser than 56 minus mu over sigma is 0.915. Probability Z lesser than some value is 0.915. That value is this thing, 1.372, and give it a positive sign. Make it obvious. Do not underestimate anything. 56 minus mu over sigma is 1.372. 56 minus mu over 1.372. Let me make this thing a little bit smaller. This is equals to how much? That is sigma. That is equation number 2. Now equate the two. So therefore, we have this thing, which is 45 minus mu divided by negative 0.994 equals to 56 minus mu over 1.372. And the rest of the basic algebra, I leave it to you. And we get two answers. One answer will be for mu. We plug in one of the equation, we will find the value of sigma. So let me just tell you what is the value of mu and sigma. Which question is this? This is question number 6. And over here, it is, this is 4, this is 5, this is 6 part A, this is 6 part B. And we get mu as 49.6. So mu is coming out to be 49.63 SF. And sigma comes out to be 4.65. Again, it's 3 SF. And that is after this concept of simultaneous equations. So yes, you have to do a lot of hard work because grades are not earned the easy way. So question number 6, this is 1054. Let me scroll up. Let me write over here 1054. That is where we are standing now. And now we are on the last question finally. And then we would analyze how much was each question worth in terms of time. So now over here, it says the number of chocolate bars sold per day in a cinema over a period of 100 days are summarized. Number of chocolate bars, number of days, draw a histogram. Now, this is about histogram. That is the first thing. And is there anything more to it? Yes. What is the greatest possible value of the interquartile range? So interquartile range is upper quartile minus lower quartile, but they're asking for the greatest possible value. Calculate estimates of mean and standard deviation. So it's also about mean and SD. So let's get started. Now, as far as the drawing part is concerned, I'll just give you the basic theme and idea. And I'll just focus on the working. So you can add 2 more minutes if I were to draw this thing, maybe 3 more minutes. So the number of chocolate bars is this thing. That's 1 to 10. First of all, convert it into boundary, 0.5 to 10.5. This is 10.5 to 15.5. This is 15.5 to 30.5. This is 30.5 to 50.5. This is 50.5 to 60.5. So my first focus over here, and let me just draw this thing, highlight this thing that I have done. So this thing that I did over here was class boundaries. Because based on class boundaries, I'll be needing the class width. So therefore, frequency over class width, let me write over here, frequency divided by class width is frequency density. So FD, that is frequency density. So class boundaries are there. And let me write over here, that is frequency density, FD, frequency density. And let me write over here in red color, this is 10, this is class width. This is 10, this is 5, this is 15, this is 20, this is 10. So what is frequency density? That is frequency over class width. So 18 divided by 10. So let me write over here 18 over 10, which is 1.8. This is 24 over 5. I think that's 4.8. 30 over 15, which is 2. 20 over 20, which is 1. 8 over 10, which is 0.8. So now frequency density goes on the vertical axis. and class boundaries goes on the horizontal axis. And let me draw a little bit. So now the maximum value of frequency density is 4.8. So let's look at the table. So this is 1, 2, 3, 4, 5. I think let's choose an easy, always choose an easy readable axis. So now that is the first one. And over here. So now this is frequency density. Frequency density, write the full form because examiner is not familiar with your symbols. This is 1.0, this is 2.0, this is 3.0, 4.0, 5.0. And the boundaries, they are starting from 0.5 all the way till 60.5. So let's say if I take this to be 0.5, so 0.5, and then 10.5, 20.5, 30.5, 40.5, 50.5, 60.5. There is enough space. So let me write over here, this is 0.5, a squiggly wiggly, a jagged line. This is 10.5, this is 20.5. So there are 10 units in between. 30.5, 40.5, 50.5, and 60.5. Right over here, class boundaries, which is the number of chocolate bars sold. So this is number of chocolate bars sold. And that's the frequency density. The first one has a width of 10 from 0.5 to 10.5, and it has a height of 1.8. So let me draw this one in red color. From 0.5 to this thing. So let me draw, I think the pencil is good. So let me go all the way up till here. Let me go all the way up till here. And let me close this thing like this. So this is perfect. And this is 1.8 over here. And that's how the rest of the thing can be done. And that's kind of boring. So I'm not going to draw that. So add 3 more minutes or 2 more minutes for this one, whatever the time would be left. Now it says the greatest possible value of interquartile range. Now, what is the sum of frequencies? That's 100. So sum of frequency is 100. That means 25% of 100, that is 25. That's the value for lower quartile. 75% of 100 is 75. That is for upper quartile. Now, look over here. Where would the 25th value lie? 18. 18 plus 24 has exceeded this value, which is 25. That means the lower quartile, let me write in green color, blue, red. Okay, this thing. So the lower quartile would be somewhere over here, 11 to 15. And when we look at the 75th value, so if I go backwards, subtract 8 and subtract 20. So 20 and 8 if subtracted, that would be 72. That means the 75th value would be lying over here. So the 75th value would be lying over here. So now over here, the lower quartile lies over here. The upper quartile lies over here. 11, 15, 31, 50. So now we have 11 and we have 15. 11 till 15 and 31 till 50. These are the values that we have. Now, what are we interested in? We are interested in the greatest value. Now, you have learned something in O-level math or IGCSE maths. That is about upper bound and lower bound. Now, for this thing, if I need the maximum value, so let me focus on this. If I need the maximum, that would be the difference between these two. If I need the minimum, that would be the difference between these two. So over here, since we are looking for the greatest value of interquartile range, that would be 50 minus 11, and that comes out to be 39. Let's say if they would have asked for lowest interquartile range, that would be 31 minus 15, which comes out to be 16. So just focus on the color. The lowest would be 31 and 15. The greatest would be 50 and 11. That means the maximum from here, let me highlight it, the maximum from here, the minimum from here, this difference will give me the maximum. And for right now, this is the only thing that I'm focusing on, and that is the answer for 2 marks. This is something extra that I did if they would have asked it the next time. Calculate estimates of mean and standard deviation of the number of chocolate bars sold. Now I need the mid value. So 1 in 10, that is 11. The mid value of this thing is 1 in 10, that is 11. 11 divided by 2 is 5.5. So let me write over here if there was a way in which I could have copied this, but I don't think so that's possible. Maybe if I take a screenshot. So that won't be a very nice screenshot. And okay, so I took a screenshot that has all these things in it. So something would be better. No, not this thing. Why is it not copying? So let me just write 110 and that is 5.5. So I just have to do this thing a little bit more. Let me make up a table over here. Okay, so now over here, this is a 5.5. We have the X value, which is 5.5, which is the mid value of 1 and 10. 11 and 15, that is 26. 26 divided by 2 is 13. And then we have 16 and 30, 46 divided by 2, that's 23. And then we have 31 and 50, that is 81 divided by 2, 40.5. And then we have 51 plus 60, 111 divided by 2, that is 65.5. So that is 111, that is 55.5. And then the corresponding frequencies, that is 18, 24, 30, 18, 24, 30. And then we have 20 and 8, that is 20, and then we have 8. And let me just remove this black color from here. That looks good now. Now, if I pick this thing up and take it over there, that is the table I need. So let me just cut this thing. And let me just paste this thing over here. Okay, there's always a problem with pasting. Okay, that thing is there. Now, what is the formula for mean? X bar, that is sigma fx over sigma f. SD square, that is sigma fx square over sigma f minus x bar square. So now what we can do is that either we do it the way of this thing, that is making columns. So let me write over here x, let me write over here f, let me write x square, let me write fx, let me write fx square. So first of all, I'll write over here, that is 5.5, that is 13, that is 23, that is 40.5, and that is 55.5. And the corresponding frequencies, that is 18, 24, 30, 20, and 8. X square, just square each value, 5.5 square, 13 square, 23 square, 40.5 square, and 55.5 square. Fx, multiply these two, 5.5 into 18, 13 into 24, 23 into 30, 40, 40.5, not 45, 40.5. That's 40.5 into 20. And let me just shift this thing a little bit down. And this last one is 55.5 into 8. Similarly, f into x squared. And of course, you can do it on the calculator. You don't have to write it down. You can write the value. That is 18 into 5.5 square, 5.5 square into 18, 13 square into 24, 23 square into 30, 40.5 square into 20, and 55.5 square into 8. And then you would add it up. So you need sigma f, you need sigma fx square, you need sigma fx square. So this is sigma f over here. And then we have sigma fx over here. We have sigma fx square over here. We will plug the values where it belongs, sigma fx over sigma fx square over sigma f minus x bar square. And then we will have values for x bar, and x bar is coming out to be 23.6. And variance, let me write the steps also. So x bar is 2355 over 100, 2355 over 100. That is 23.55. You can leave the answer in the exact form, or some people, they round it off. But I think if it's exact, there is no rounding off. Even in the mark scheme, they have round off. I don't know the reason why. And when we talk about SD square, that is sigma fx square, which is 77917.5 divided by 100 minus 23.55 square. And this comes out to be 224.57, 224.57. Therefore, standard deviation is coming out to be 15.0, correct to 3 significant figures. So that is the kind of working that's needed. And now it's 11:09. So let me go up and right over here, that is 11:09 p.m. Now, for each question, let me write the time limit. So 7 minutes for question 1. 10:18 till 10:23, 5 minutes, 7 minutes, 6 minutes, and this is 4 and 3, 7 minutes, and 43 till 54, that is 11 minutes, and 54 till 11:04, that is 10 and 4, that is 14 minutes with all this thing. So now, how many minutes are there altogether? So let me add it up. 7, 5, 12. And plus 7 and 6, 12 plus 13, 25, 25 plus 7, 32, 32 plus 11, 33, 43, 43 plus 10, 53, 57. So even with all the narration, I have done the paper in 57 minutes, which is like A star time. Okay. So that means if you do it by yourself, you don't have to explain it to anyone, of course, not in the exam paper. So you can easily finish this thing in 57 minutes, whereas how many minutes do we have? We have 75 minutes at hand. So that was a thorough paper of May, June 2020. Hope you enjoyed it, and stay tuned for more content. Take care, everyone.